Hi, good afternoon, everyone. Welcome again to the StorTrends Virtual Lunch and Learn. My name is Tyler Newberry, and it's the top of the hour here. It's 1 p.m. So we're going to go ahead and get started with this excellent presentation, this full coverage of different storage products and technologies in the market today. Again, my name is Tyler Newberry. I'll be your host and moderator for today's event. In just a moment, we'll have our Senior Solutions Engineer, Mr. James Dykowski, joining us for the presentation, and we'll be getting started shortly. Just a couple of quick things. First of all, regarding the pizza, if you are in a pizza delivery zone, your pizza should be arriving in the next few minutes or so. That is, if it hasn't arrived already. Sometimes delivery people will get caught up in traffic or what have you, so at least give them until 1:10 or 1:15 Eastern time, and if they haven't arrived by 1:15, please shoot me a note on the email or give us a call, let us know, and we'll get that situation squared away. Second, during this presentation, please ask questions. There's a Q&A communicator at the bottom right-hand corner of everybody's screen. Please feel free to ask us any questions throughout the presentation. We want to tailor this as much to what you guys are hoping to learn more about storage-wise as you're hoping to learn. We're an open book, so just ask us anything, and we'll be happy to answer whatever we can for you on air. And if there's anything we can't get to on air, we'll shoot you an email this afternoon or something like that with a response. And finally, it is rare, but occasionally we will have technical difficulties during the event. WebEx is not always perfect, so if we do have something come up, like the screen gets a little grainy for a second, or we might lose audio, for a few seconds or so, just give it a little bit of patience. These problems usually resolve themselves within 30 seconds or so, if that. So. Other than that, though, I think that's all I have for you. I'm going to go ahead and introduce us to the man of the hour, the man with the plan, and a stand, Mr. James Dykowski. Hey, James, they're all yours.
Hey, how's it going? I am James. That was Tyler. As he said, we cannot reiterate enough about, even my mother doesn't want to hear me talk for 2 hours straight, or an hour straight, I guess I should say. So definitely ask questions. Tyler will just interject and throw it in there, and hopefully it'll kind of, maybe somebody else does have that same question or something like that, so we can kind of get that all ironed out if there is something that I just glossed over or didn't explain as well as I should have or anything like that. Definitely the idea is to kind of get, the information across the wire here, and just, get crystal clear about where everything stands. So I'll start with for those guys who have not heard of who in the world is American Megatrends, what is StorTrends. So American Megatrends, you can see the little logo in kind of the center left of the screen there. That is the AMI triangle. We've been around for 30 years. We were founded in 1985. And you can see we have a worldwide presence. Somewhere, somehow, we're in over half the computers in the world today. And this has been the case for many years, over 20 years at this point. You can see just a lot of presence if you haven't heard of us. Now, of course, with splash screens and stuff like that on the BIOS, really that triangle's less predominant. Now it's usually in a corner or something like that. So with American Megatrends, we are founded and have always based our business around the BIOS, AMI BIOS, and then Aptios, the Intel 64-bit version, stuff like that. Obviously, that's a huge stake for us. And then, of course, Mega Racks, the remote access controllers, which you probably haven't heard, but we do OEM this out to, Supermicro and all kinds of guys. Just about everybody has used it somewhere, somehow. And then we have the LSI, the Avago logo up there. And one thing interesting about that, so we developed the LSI Mega RAID controller, now Avago Mega RAID controller, in 1996. We built that up, and then basically we thought everything was going to kind of go down to the board as everything does kind of consolidate. So we did sell that off, and they just expected it to go another route, which they're still one of the main shippers of RAID controllers in the world today. Well, that same team, we actually brought them back, very successful team, and with that being said, basically we built up this StorTrends product line that we're here to talk about today. And the technology around SAN and the benefits and infrastructures and stuff like that. You can see to date we have 114 granted StorTrends patents. We have over 150 that are, if you look at granted and then also patent pending. And then thousands of StorTrends installs. So We're excited about the product line, about the kind of going out into the channel and stuff like that, as we were focused on OEM, to where now we're kind of going out there. And so now, here with the sand solutions, you can see the StorTrends 3400, our spinning disc solution, 3500 hybrid solution, which we released 2 years ago, and then our 3600 and 3610, which are all flash offerings with dedupe and compression in them. And then, of course, we expand by a 3U shelf there. So with these, you can see basically we're covering the gambit of, what a requirement might include for a particular infrastructure, to where not everybody really fits with a 3600 all-flash array. Obviously those drives are more expensive, but, just kind of depending on where you fit, we can actually provide a solution for you and not just talk whatever we have at you, basically.
Hey, James, let me interject real quick. We've got we seem to be having some technical difficulties where some of our people are not able to view the screen as showing as blank. Maybe we should just try refreshing the PowerPoint real quick.
Just stop sharing.
Yeah, we're stopping sharing. We're just going to reload this real quick. Hopefully everybody will be able to see. It is interesting because it is coming through on our end. Not sure why everybody would be seeing a teal screen or a gray screen like some of you are. Looks like we have reloaded it. And boom, everybody can see it now. Okay, again, sorry about that, everybody. Thanks so much for your patience and letting us know. And James, now you may continue with this wonderful presentation. Thanks again, everyone.
Yeah. Okay, I thought it was going to be a question. So just in case y'all didn't see it, here's just kind of the worldly view of what I was yapping about. And then here's the table of just kind of different units. And, of course, if you guys want to ask us anything down the road, if you want to see your own presentation, whatever, we're always available, basically, to answer any questions and or basically kind of give a presentation.
And that brings me to my next point. We did actually have a good question come in. Will this presentation be available for download? Short answer is yes. We're actually going to upload this presentation. We're recording it as we speak. We'll be uploading this to YouTube tonight, and it will be available tomorrow. I'll make sure to email everyone the link to the event so that if you want to share this with a colleague, a boss, a friend, whomever.
Your mom.
Your mom. Depending on how the presentation goes, maybe your worst enemy, if it turns out to be really boring. We'll have it available so everyone can view it if you like later on. And it'll stay up on YouTube for at least the next year or so. So certainly no rush there. James?
For a year?
Yeah, a year, 2 years, however long. Until the information becomes obsolete.
Okay. But even then it might still stay up there.
I wouldn't recommend it.
Oh, okay. So we'll go on from here. So now we're going to talk about the actual learning part instead of the AMI StorTrends part. So here you can see just kind of, and this isn't to scale of timeline or anything, but, just kind of how everything's kind of grown over time, to where you did have the standard spinning disc solutions, and then hybrid comes out. Nimble really made a huge mainstay for hybrid and in the infrastructures today. And that was kind of the beginning of really pushing flash solutions and stuff like that. So there's something to say for that. And then there was this server-side cache and hyper-converged kind of thing. They're actually probably closer together when it comes to mainstream technology, right? I'm not saying when this stuff was invented. I mean, heck, SSDs were invented actually in the 50s. So, this is actually an old technology that just never had the real requirements that it has today in the main uses. And, of course, the expense is now greatly lowered. So anyhow, you have server-side cache, hyper-converged solutions, and all flash solutions are now really becoming more predominant. So as we go, we'll kind of talk about each of these just kind of individually, and I'm going to keep this quick. At the end of the day, the idea is consolidation, especially for this one. So, you have similar capacity. Of course, with the all-flash array on the right side, we're looking at a 3.5 to 1 dedupe ratio to get to that capacity. That's a very standard number for us. It's not a bunch of marketing, garbage. And one thing to say there, we do provide POCs absolutely free, and you put it into your environment and you see how it works, how it actually fits for you, and stuff like that. So that's a whole side note to all of this. But anyways, there's a huge value, obviously. You're looking at a lot better, greater latency. I guess I should say reduced latency, but it's better. From an average of 10 milliseconds, we'll talk about that here in a second, down to sub 1 millisecond. A lot higher I/O potential, a lot less rack space, therefore less power, less CPUs, everything, less spinning drives. Plus SSDs are just cooler and take less power than spinning drives anyhow. And then, of course, up front, you're looking at half the cost. So, and this is even the case with our spinning drive arrays, and there are specific situations for them, especially high throughput, high data amounts, especially unique data, to where you have to do a spinning disk environment, and that's just part of that data set. So it is what it is there. So anyways, you can see the actual value here and, obviously the OpEx down the road.
Since we're on this slide, I think it'd be a good point for this question. On one of the registrants technology question, they asked about the reliability of a spinning disk versus a flash drive. Is there any difference there between how long you can expect a flash drive to last versus a spinning disk? Is there any performance metrics that we need to keep in mind there?
Okay, so absolutely. And there's two major factors. So you look at reads and writes. If you are spinning this, this disk around for about 10, 20 years, you really have an expected life expectancy to really go down to limited to 0, just based on what the physical capabilities are of it. For an SSD on just reads, like I'm talking about, you're looking at 2,000 years. Now, conversely, you're going to be looking at the same thing for writes on the disk. Now, on the spinning disk, though, it's not limited by how many writes you can do to it. It's just basically a time variance, and then based on, hey, this thing can only spin, these bearings are only going to last so long, and including all the heat factors and all that kind of stuff in there. To where on the SSD side, now we're limited by endurance. We can only write to these cells because they physically can only handle so much data. And actually that 72 petabytes for an enterprise class drive. Well, we extrapolate that down to 5 years per day, you're looking at 10 to 20 drive writes per day for each SSD, enterprise class SSD drive. Now, we do support both of them, so we support SSDs on the enterprise and consumer grade. The consumer grades only support 1/5 of the drive being written to per day for 5 years. So there's a huge factor there in the life expectancy and what they can actually do. Do you have a question, or you were just?
No, I was just listening intently, man. That was
beautiful,
He was
staring me down. He was kind of pointing at me a little bit, but then he might have been scratching. We don't know. So anyway,
I don't scratch. No.
Oh, okay, perfect. Okay, so we're going to go on. Yeah, that's just kind of consolidation, I guess, is the main key there. And then here you can see, so server-side cache is a little different animal than an all-flash array. But if you're looking at 10% worth of your environment, say it's about 40 terabytes, so we're looking at a usable capacity of 40 terabytes, and you were like, well, what do I get versus of an all-flash array if I just took, in this case it'd be this example in a 40 terabyte environment, we're looking at 4 or 5 hosts. It's about $25,000 end of the day, including the, whatever flash cache kind of provider you use. You're looking at about $25K usable or dollars for that environment. And now, what do you actually get? Of course, there's no more rack space, but we'll just assume you have PCI slots for whatever, or SSD slots, and you're putting in the power, CO2 emissions. It's minimal. Now, where do you get for I/O? So your reads, online analytical processing, heavy reads. Assuming it's actually populated in the flash, which we'll go ahead and give that. You're looking at 400 microseconds, very fast. For writes, heavy transaction processing, so we show over 10 milliseconds, and I have customers to back this up. As somebody, I'm sure somebody here has a perfect environment where they're doing writes and it's mirrored fast and all that. But the few environments I've seen, they do have a very high overhead for that. And what they have to do is they have to mirror this data from one server to the other. And by doing that, basically there is overhead, and it really just originally wasn't designed for that. To where the all-flash array writes are rated. You're going down and then coming back, and it's done. You don't have to worry about those kinds of things. And then, of course, we have kind of algorithms to kind of manage that data and all that stuff. And then, of course, when you start mixing these together, you can look at what your average latency is going to be looking like, as opposed to basically a sub-1 millisecond type latency here. And, of course, the value, the CapEx, up front, it's kind of expensive when you look at the overall, granular value of what you're getting for that technology. and all that kind of stuff. So,
James, mind if I interject here for a moment?
Yes, sir.
Very good. Then I'll save it. Just kidding. So
I was kidding.
Had a great question come in about application environments where compression is discouraged. Do you see a lot of those types of environments out there where compression may not, and deduplication, I'm guessing for that matter, within that same breath? Are these ever discouraged in particular environments? Are there environments where, you know, these types of technologies would be counterproductive to what they're trying to do?
Yeah, you're talking about on the fan side, basically?
Yeah.
Okay. Yeah, there absolutely are. So just all unique data, highly compressed data, stuff like that. So the simple thing there is like a video camera. That's compressed data, and it's absolutely unique, every bit of it. That would be really just a waste of time, as the camera's actually, you know, compressing everything, and then basically you're kind of going from there to where it would be just a 1-to-1 ratio. And actually, if we talk about that ratio, which we'll talk about here in a couple slides, there's no value for you. You can, hey, you know, if you want all flash and you want to just go against what we're saying or what we're recommending, and you just want that, I mean, that's fine. If, you know, if I had $1 trillion, I might just do that too. So, yeah, so the value there could be limited in its specific environments. And we'll actually talk about those kind of environments as well here in a second. So that'll actually be more pertinent here in a second. And then if you're looking at hyper-converged, huge note with hyper-converged, though, I mean, this is a full rip and replace of your environment. So, again, it's the opposite of a server-side cache environment now, to where instead of it just being a piece of your server, now it's your whole server, your storage, and everything. So, of course, it complicates things, but people want to see how it's comparable. And, you know, one thing that's really huge is vSAN lately. So for the 40-terabyte environment, this is excessive. I had somebody run these numbers on using their VMware tool. However, you know, I think you can get this done a little more efficiently, but just doing this, you're looking at your latency is about 10 milliseconds. Your IOPS, you can get about 80,000, and I'm sure with this many hosts, but I do know that this is not capped. If you look at a 4- or 5-node environment, you're not getting that many. At a minimum, you have to have 3 to 4 hosts. You can only handle one host failure, so it's not like you're getting anything above and beyond, you know, what like a dual controller SAN or a dual, any kind of HA environment would provide. And then, of course, you know, in this case, it's a lot of rack space. The power and all that stuff, that does include your servers and stuff like that. But, you know, your CapEx is very expensive. And then, you know, if we talk about the actual environment, what is actually happening? So you have your VMs, you have your host in the dark blue there, and then you have that data down at the bottom. Now, you can see you have the data. It is assigned to each host. Now, you also have it mirrored to a different host. You have to. That data has to be somewhere else. If that node 1 fails, basically 1 and 2 have to start running off of host 2 in this case. Obviously, that would probably be more like 1, 3, 2 on the bottom right there, and so you'd have them split up, assuming everything's dynamic and perfect. Now, the pro with vSAN, obviously, if you already have VMware, oh, okay, and you already have 3 hosts, and you already have the disk bays available to do it, you know, there is a huge value in that, as you can really reduce that CapEx up front and just really include the drive increase and the licensing and stuff like that, which is there. Now, the cons, the mirrored writes, the performance of this, that 80,000, that is 100% reads. There's no way they're getting that on writes. I know that for a fact. We've run it here ourselves. Max capacity, I mean, this is half the node of what you can get for one individual piece of capacity. So you would have to beef this up substantially, because, I mean, just say data 1 is half the node. Well, that now also has to get mirrored to the other node, stuff like that. And then expansion, you have to add another node, quite honestly, to do that. And it has to mirror the data. Of course, it's got to shuffle data around, which is very inefficient. But, I mean, it's a one-time thing, right? It's fine. You get it mirrored and it's done. Or you add shelves to each one. Well, you do have to add shelves to each node if you do that. Again, it's probably cheaper just to add the node, quite honestly, than just adding shelves. So either of those arguments, however you kind of want to go there, it's not perfect. We'll just say that. Now, if we look at the hybrid array, so just to kind of fill this piece in here, so if we have again, an all spinning disk array, and then an all flat or a hybrid array. Similar capacities, and the 45 terabytes just kind of didn't really match perfectly, and it is what that happens. And now you're looking at about sub 3 milliseconds. Quite honestly, with the data intelligence of StorTrends, we're looking at sub 1 millisecond for the active I/O in the environment, and we're watching the I/O to know what's active. We keep only that in the SSDs, but I give them the benefit of the doubt there of, oh, well, what if you miss? And there's always, some people that come to me and say, oh, there's no way that's possible, and so fine, I'll give you 3 milliseconds, fine. It's way lower than what you're looking at in an all-spinning disk environment, and a heck of a lot more consolidated down into this one 3U unit. And of course, it's cheaper up front, cheaper down the road, because you are spinning less disks, you're less power supplies, everything, CPU, all that stuff. So now if we do compare these two, and one thing to note, I'm talking about, I have the StorTrends units up here, but if you're looking at an all-flash array versus a hybrid array, this is where your comparison really is. And so in this case, why do we still sell the hybrid array? Well, this is why. Basically, if you don't get that 3.5 to 1 example there, and you get a 1.8 to 1, and I'll talk about how that's possible, now you're looking at the usable capacity, instead of 40 terabytes, you're down to 23 terabytes. Well, hey, I got 30 terabytes, and I wanted to have space to grow. I have to have that. So that's where this 3500 comes in. We haven't added compression and dedup to it. We did the testing. There is an overhead to that on spinning drives. We're not going to kill our performance. This is the highest performing hybrid array in the market, and I can prove it to you day in and day out. And we have non-biased people saying this, so it's not even like I'm just saying this. Of course, the power is a little more efficient. CO2 emissions is more efficient, and you save about, I think it was, what do we have here? It's in the notes. So it's about $200 a year between the overall difference, just because of that power right there. So I mean, $200, it's a factor. Obviously, it's not a big deal when you're spending this much money, though. Especially over 5 years, you're looking at a $1,000 difference. So that's kind of almost a negligible argument. Obviously, depending on how much flash and how much spinning disk you would have, though, as well, capacity-wise, because we do have some customers that are way up there. So, and you can see the value. We talked about CapEx at $1 per gig, and it's just the value for what you're receiving there and stuff like that. And some people are even like, oh, you know what? Hey, it's sub 1 millisecond. I'm paying $1 per IOP, whatever. Well, IOP is subjective here, but say $1 per latency reduction, whatever your argument may be. So, anyhow, we'll go on. I'm rambling. So why doesn't everybody just have all flash everywhere? Of course, the prices of SSDs are high. The endurance is limited based on the physical architecture of it. We've talked about that. So now you have dedup and compression, so now you can reduce the amount of data and make that value there. Well, of course, the expectation, we don't know. A lot of times it's just, oh, yeah, I think I'm a 3 to 1, okay. And then, of course, there is overhead with the performance of dedup and compression. And so that's kind of why we do have the hybrid and all-flash array. And what the challenges are, and we'll talk about how we kind of deal with these challenges in that regard. So when we talk about latency, so we kind of compared the hybrid and the all-flash, and everything's sub 5 milliseconds when you look at those two units. If anybody out there does have all-flash, or they're a heavy analytical processing, heavy reads basically, and they have server-side cache, what have you, you guys are all sub 5 milliseconds, probably feel great about the environment, no big deal. You're not overloading what you have infrastructure-wise, and that's perfect. That's great. Most everybody is in this 5 to 20 milliseconds range. If it's not at peaks, it's your average, and that's because you're on spinning drives and you're getting that performance. You're really not going to get lower than 3 milliseconds ever with 15K drives, and you're never going to get that low with 7K drives. Just because there is a limit to, hey, the disk is spinning so fast, you can only get the data so fast out of it. So, of course, the standard, though, when we'll talk about that in a second, for that, it's about 14 milliseconds for a 7K drive, 7 milliseconds for a 15K drive. The latency is half. It spins double the speed. That's not counting seek time and stuff like that. But we manage that stuff, and I'll talk about that separately if you want to know how we do that. But anyways, we do watch where the data is within the disk as well. So anyways, 5 to 20 milliseconds, it's probably where everybody's at. Maybe the people that are standard on the higher side of that are hitting peaks of the 20 to 50. It is slow when you're running your job or this or that, whatever your task may be. Say there's a database, you know, a month-end report, whatever. And then those over 50 milliseconds, it's painful. I want as fast as I can get at this point because it's just dog slow. We understand that. And then, of course, if you look at the 800 milliseconds, if you sustain this, and we can see I have a black hole there, if you sustain that, basically VMware will start, you know, freezing IOs and stuff like that, and at 5 seconds, it'll actually just shut down the VMFS. So getting out there is kind of the absolute no man's land that you do not want to be in.
So, James, I had a couple of great quick questions come in. These should be pretty slick, but pretty slick, yeah. Someone just wanted to know about how good a compression ratio someone might be able to expect in an environment that's heavy in PDF-based documents. Do you see that those are, you know, fairly compressible or not so much?
All right, we're jumping the gun because the other one kind of goes into that too. So we're going to hit it.
Okay.
Like 3 slides, I think. Yeah.
Very good. And just real quick, another quick question: Are all these units with chassis, are these all dual controller or any of these single controller?
Every one of these are dual controller units. Yeah.
Perfect.
Yeah.
Perfect.
We keep this as reasonably highly available as possible. Of course. So taking those latency numbers and now looking at, you know, SSDs versus 10K versus 7K. You know, what do you look like if you hit this mark of 100,000 IOPS? Okay, well, it takes 4 drives on SSD will easily achieve 100,000 IOPS, no big deal at all. 15K RPM drives, you're looking at about 285 disks. So obviously these boxes are not to scale. And so you can see 400 disks of 10K, 500 disks of 7K. Now, who in the world would do 500 disks? I actually have seen it in the last 6 months even, I should say. So people are still doing that stuff, and there might be a use for it, but at this point, it's not reasonable, I'm going to say, and you'll see how that progresses as we go through here. But yeah, that's kind of ridiculous. But anyhow, and for those that do have that, and I just saw one post about we have a lot of disks in our fan array, which is hilarious. So yeah, so some people are there, and really we are still talking about consolidation. And I mean, there's just a lot of overhead by having all those drives and stuff like that. And then once you get down the road, especially if they're spinning drives, they start popping off because of medium errors and all the smart alerting that's available now. Now the disks are really starting to be smarter than they really should be, maybe, or than they could be. But obviously it's to prevent from hard failures, but now they're never going to last as long as those old SCSI disks that you had 20 years ago that lasted 15 years, you know. Because they didn't have those capabilities, they didn't know anything about, you know, when will I fail and stuff like that. So that's why disks don't last as long as they used. Spinning drives don't last as long as they used to anyhow. So anyway, so this is that, and then now the correlating latency, though, at 100,000 IOPS, even if you have the 500 disks, at that load, you're looking at 15 milliseconds of latency. For SSDs, now you're looking at 1 millisecond of latency at that load. So it's so much more efficient overall performance-wise, and obviously that's why we are really standing behind SSDs in that regard and really pushing forward with that. So now we're getting into dedupe and compression. So how can we fit it in there? You know, Permabit released these numbers. I like the chart. So I have the chart right here. So you can see here 44 zettabytes is what they expect by 2020 to be the total overall amount of data in the world. It's probably going to be higher than that even, I feel like. So anyways, you can see how much of that data is what they expect to be duplicate data at that point, which is the same percentage as what we see before. And of course, you know, older numbers, it's like the Dow Jones. I don't know if anybody's scrolled back in the Dow Jones, but this all looks the same as you scroll back. So even from that 2013, going back 15, 20 years on that, it looks the exact same, you know, exponentially. So you can kind of see how that works and how data growth is really applying today. So here we'll talk about dedupe and compression, and if you guys are in the market for, you want dedupe and compression in your environment, the next thing you buy is going to have this technology. Here's why we do it this way and why anybody else that you purchase, if it's not us, should do it this way. So inline is the first thing. Always inline is what we do. There's a reason for that. A, it's consistent performance. You're not questioning, oh, well, is it going to be, deduping or not? B, by doing it inline, we are always writing deduped and compressed data to disk when it's unique. So we're not wasting endurance by writing a bunch of fat data, undeduped and compressed data, because it's not inline, it's out of band, and then going back after the fact, if you have downtime, to basically then dedupe and compress it down the road, then rewrite that data down to disk. That's wasting your endurance, and the endurance is limited here. So that's the inline piece. So deduplication, we do this first. There's a huge note there. By doing it first, we get a more efficient dedupe rate. If you try to dedupe compressed data, the smallest little change, say it's a file, say it's a docx, right? That's a compressed document file. Say you change just the header of that, it changed the full compression algorithm for that full block, and so then that's now not unique. Say you did actually do a bunch of changes in that document, none of the stuff in between is going to get deduped because that compressed block is now changed. So they're all going to look different. So with that, we keep our hash table in uncompressed data to be more efficient. Now, the fact about doing compression last, for any non-unique data, we're not wasting the CPU and memory overhead in compressing the data. There's a huge, A, it takes time, B, it takes resources, right? So if it's non-unique, we see it's deduped, done. We're done with that. We update the metadata table and we're out. Now, if it is unique, we'll then compress it and then write it down to disk. This is absolutely the most efficient way to do this. I don't care what anybody else says. And again, we will POC this. If you have somebody else in there, we'll put ours in right next to it and you can see it. So in that, we're reducing the overall storage I/O. This is a huge performance increase because we're just not wasting anything possible here. And then, of course, the endurance increase of just doing the bare minimum of what we need to do down to disk. With that being said, 3-to-1 ratio is a very normalized ratio, and that value going up is obviously where the all-flash array really kicks in and really shines and shows value over even a hybrid array that's out there. So, of course, there's huge cost savings in that. So now that 3-to-1 is a huge note here. Did you have a question?
I did, actually. We had a really good one come in, something that I don't think we get asked very often. It's asking about like the rehydration period for deduped data. Is there any sort of I guess to be kind of general here so everyone can kind of take something away from it. Are there any like stiffer penalties with the rehydration and rebuild process for deduped data versus undeduped data?
So everything's deduped, so in that regard, everything is consistent. So it's kind of confusing there, I'm sure, but at the end of the day, it's just as fast as the hybrid solution with the spinning drives, and then of course just raw data to the SSDs. It's just as fast as that, but everything's all flash. So now you're getting that consistent performance throughout the whole, any block in your environment that you touch, it's the same performance out of that. It is slightly slower. It's probably, I'll say, a 10% degradation. If you just matched, say you had 4 SSDs in the hybrid and you had 4 SSDs in the all-flash array, that performance match to match would basically be 10% faster on the hybrid. However, that's only for the hot data. The randomly accessed data has to go into our caching algorithm, and that has to get hydrated. So there is a performance penalty just in the hybrid going because you have spinning drives versus the actually lesser performance penalty of going to SSD drives and hydrating data. So if you look at it both ways, there are penalties, and that's why the performance is very comparable. That kind of makes sense?
Yeah.
I know we never get that question. So
it's a good one though. So I want to throw it out there.
Absolutely, it's perfect time for it. Okay, so say we have, we'll just do 10 terabytes each, whatever. So now if you just have compression on these types of workloads, so backup, obviously backup's not a normal thing, especially for an all-flash array. It's just to show that kind of, that situation, I guess we should say. So then you have a VDI type environment, 1.7 to 1, a database environment, Exchange, user directories, So now user directories is going to be a big note at the end of the day. That is whatever your users are doing. Myself, if I'm using my user directory on my share, we're looking at compressed data. This PowerPoint right here is compressed, PPTX, Excel is compressed, DocX compressed, and just about everybody's using Microsoft Office or OpenOffice, and of course they're compressing the data as well. So you'll see how the user directories compressed data really factors into all this stuff. Now, if we just do deduplication alone, here's where the numbers kind of look like. And so now, why do we do dedup and compression together? To really squeeze the most out of this. You can see the 35-to-1 backup, and that's just kind of the baseline. That's the best case scenario. You have the VDI environment, 33-to-1. Now, this is a perfect VDI environment to where you're looking at one profile, and it's the base profile, and you're just spinning that same thing out. Of course, this reduces down. Normalized VDI environments are 5 to 7, and that's with, multiple profiles. Of course, the OS is in general deduped and stuff like that, but that's where you end up being. And then database environment with workflow is a huge note here. So the standard database environment, you're looking at a 2 or 3 to 1, but with workflows, the big key, and and we're just showing you where the huge values are here. With that, you're having, these database spinning off. Say you have a reporting server that, hey, this database, we just take a snapshot, or, hey, we make a copy of the database to this other volume, and then we report off of that, and then basically keep the active database for other, other things. When you start spinning off those databases is where the workflow comes in. That's where the huge, huge advantage is for the all-flash and dedupe and compression in general. And in Exchange, there's this story I tell it every time because it's so critical. So we have a 10-terabyte Exchange environment, and this was one of the first ones we put this in. Of course, you put it into a customer environment, and there's always something new or different, and that's just why it's so important to have vetted, not just any storage vendor out there. You want people with installs. So we have 10 terabytes. They had Exchange compressed, the application side compressing. That went down to 6 terabytes. Hey, that's not bad. That's a 33% or so reduction. Okay, well then they put that on our environment, on our all-flash array. That went to 3 terabytes. They came and they were like, hey, 6 to 3 terabytes, that's a 2-to-1 ratio. That is not a 9-to-1 ratio. What's happening? How can I possibly be doing something different with my Exchange environment, outside of this workflow caveat or, oh, it's a perfect VDI environment. This is Exchange. It should be 9-to-1. Okay. So we dig in. Of course, they have compression enabled. Of course, we disabled compression. It went back up to 10 terabytes total, but on the StorTrends array, it's 1 terabyte stored. That was a 9-to-1 ratio because it was an uncompressed database. That same story goes into user directories. This is all compressed data. You're, in general, going to get a 2-to-1 ratio in this case. So this is how all this kind of fits in and ties together. And, for the infrastructure guys to where, hey, yeah, we do a little bit of everything, we'll just put it on there. In general, you might be looking at, depending on how big your databases are, if you have a VDI deployment or if you have your VMs, how big all these different workflows are and what you really need to do with them. So.
Very good. We have a lot of great questions coming in, so we're going to do our best to get to all of them today during the presentation. If we aren't able to get to all the questions today for some reason during the presentation, we want to be very mindful of your time. So what we'll do in that case is we'll send over a quick explanation to you via email after the event or something like that. And then, if you have any questions beyond that, feel free to reach out. But I have one question incoming about deduplication on different volumes. Do you ever recommend, turning off dedupe on some volumes and some leaving it on? Is that even a possibility out there? How does that?
Love it. Yeah. So our competitors definitely turn it off and turn it on by volume and stuff like that. And I love that. So that is fantastic. One thing we don't have to worry about there is doing that. If there's by chance just the smallest little bit of chance that, hey, you know what, maybe there is a dedupe block in there, we take advantage of that. We do definitely this on the full array, so we don't care by volume actually what data you have in there or whatnot, and we do dedupe across the whole array. In doing that, they're saying, oh, well, it's a low dedupe rate anyways. But, you know, we also are doing compression as well. So we wouldn't want to not compress data if we can as well. So, so there's all those kinds of pieces in there that kind of play into it. But no, it's absolutely possible. We do not mess with that because there's no sense for us. We don't have that big of a performance degradation in doing deduping compression to where we have to worry about that because we are on all-flash array here. Okay, so looking at actual applications, you know, if you look at the VDI, this is just standard VDI environment. Of course, the StorTrends down there at the bottom, but anybody, you know, what have you. So now, you know, just comparing the overview of hybrid versus all-flash, what are the kind of benefits and differences there? Of course, you can pin volumes to certain tiers, which is very important. So you have your replicas where all your link clones kind of spin off of. That needs to be pinned up high. Temp OS space, each of those desktops thinks that they're actual VMs, so or actual desktops, I should say. So they update their OSs and all that stuff. You need that to be pretty fast, and it's all writes. It's almost 100% writes for that data. And then you can see user space, so depending on if you have persistent data or not for your users. And here I just put them in the middle just as an example. And then, of course, golden images. The only thing that spins off of the golden images are basically the replicas. Everything else goes off the replica. All flash, you don't have to worry about, obviously, you know, hey, if you're not in a VMware environment where you can't take advantage of those primitives, hey, you know, I need those golden images to be fast. Snapshots, say you want to mount a snapshot and you want it to, you know, have the same type performance and stuff like that, you don't have to pin it down, which you don't have to pin it down on the hybrid either, but this is just for instance to kind of show how that fits. Databases, you do have a hot tier of data within each database, and then, of course, cold tier. We'll talk about that here in a second. And similarly, pin volumes, of course, you can just have all flash for all your volumes. And the snapshots, again, if you wanted to mount a database and do a test or whatnot, you'll be getting the same performance as your live database instead of a, you know, a degradated performance. DR, one thing that we've actually, before the SSD influx and all that stuff, our primary thing was doing just disk-based storage and then, of course, replicating that data. And this replication, SAN-to-SAN replication, this is the fastest replication you're going to get inside of here. It's wide area data services is kind of the piece in between there. We do WAN optimization, which is our own patented technology, but it's similar to Riverbed or Silver Peak. And then compression and deduplication on top of that for each individual block. So we're reducing that data and then shooting it across. And literally, if you're, and you can throttle the bandwidth down, but if you're at 100% bandwidth with our replication, you won't be able to get a web page through there while you're going. Say that's an active situation. In a hybrid solution, you can certainly pin the DR space down to tier 2. The DR space, by the way, does act as backup space. It's a very high dedup ratio because we are, you know, our snapshots are natively 64K and all of the deduping compressions at a 4K level. So even the snapshots, because they're looking at larger blocks, it actually is highly dedupable. So with that, we're very efficient when we do have that data on all flash arrays, and this is the instance where that is an actual, or that is part of actuality. And here you can see, obviously, if you do failover, your DR space doesn't have to promote into the tier, and you don't have to worry about the caching algorithms kind of get stuff up. You instantaneously have SSD performance. So very nice there. And then how do we know, you know, what I'm saying is not just a bunch of coming out of the garbage can here. We have an iData tool, very similar to Dell DPAC or something like that. You download it from StorTrends.com. Either deduplication tool, so you can actually test and say, hey, this database gets this ratio, so you can actually see what you're looking at there. That is only deduplication, though. It doesn't include compression, and we kind of factor that in. And then you have the iData tool, which will actually give you IOPS, throughput, queue depth, all that kind of stuff. When you download just the iData tool specifically, you just put in the server IPs. You can either do a discovery on the network and it'll populate, or just put in your specific servers. Select VMware Windows. If it's a vCenter, you can actually select that, and it'll populate all your hosts for you. And then it'll output this PDF. You send the file to us, and then we basically have an engineer, run through it, and then basically we send you a PDF giving you all this information. And then here's while it kind of runs. And you can run it, we did, one thing that came after the fact was doing desktop profiling, which you can see the Windows symbol here. But of course, Exchange, SQL, what have you, to try to just find out where you're at, IOPS, latency, throughput, all that kind of stuff in your environment. And it helps us actually pinpoint what exact solution is the best for you, because we give a lot of options when it comes to, SSD space for enterprise, consumer, or if it's a hybrid, how much actual flash space do you need? And then one thing we had SSG now review the iData tool. They tried to break into the iData file, which was encrypted. They couldn't. They got the key, and then they did find that it is only the result of the WMI counters and all that stuff. So there is no data or anything like that. So we've done a little due diligence there just to make sure that, we're not taking anything that's not supposed to be ours. When it comes to infrastructure, so the data that provided us, it tells us how much hot data there is, and you can see the yellow sliver here. This is 100+ accesses within the last hour. Now, of that, that's a low percentage of what you really need for SSD space. And 100 accesses is nothing even for SSDs, but it does show multiple accesses. If I went to 1,000, this would be an even smaller sliver. As you can see how the scale kind of goes down here, so you'd see even smaller sliver here and here. But another key thing is 60% of most environments, and of course there's caveats, and this actually came at a bad time. It was a month-end report that ran, so it did touch the whole environment there. But in general, that was a one-time thing, and here you have a 60% of your environment absolutely untouched. There's no sense of having that flash space for that, or if you do, have a consumer-grade space to where, hey, it's just sitting there. You can read from that space as much as you want. For database specifically, so that was infrastructure, so just kind of everything, you can see how efficient databases are. And even if you think your database isn't, there's actually one of these in here that the customer doesn't really think that theirs is that efficient at all. And quite honestly, it actually is pretty efficient when it comes to this piece of things. So you can kind of see percentages. So 10% really covers a good amount here for that. And now if we just kind of overlay them and talk about, space and stuff like that, the stuff that's accessed over a time within the last hour, you're looking at about 3 terabytes if you're looking in a 40 terabyte environment. Now 3 terabytes, you're starting to get up there with, how much that costs to get that much flash for, a SAN environment. But what if you really wanted a day worth inside of that? Hey, that costs a lot of money. Dedup compression really kicks in here, though. You're looking at a 3 or 4 to 1 ratio. That comes down to 3 terabytes. So now you can cover that space in enterprise class SSDs, and you're fine and dandy. And even so, few and far between do I see over a 60% write ratio and 40% read ratio. So you're really covering that endurance, and in factoring your life of the array, you're really making a huge value by kind of maximizing the space for the enterprise and then also the consumer-grade drives. Did you have something or no?
Yeah, I did have a real quick one. So I think this should be a fairly quick one. What sort of compression ratio, and I guess this goes for dedup as well, would you expect to see on, high-definition video storage? Is that typically highly compressible data?
One to one, basically, yeah. Everything's going to be unique. Unless you happen to store the same HD videos next to each other for some reason, everything is going to be a one-to-one, pretty much original data, because, like I said with the video example, it's all unique data, and that's why we still have the hybrid array, and that's why we have the all spinning disk arrays and stuff like that.
Very cool, very cool.
So yeah, that was a quick one. Okay, so StorTrends, and what are we doing? We watch all the data. So we're watching reads and writes. Not only are we watching the access counts for each thing historically, for each block, but we're also watching, hey, are they reads or are they writes? If they're writes, we want that in our enterprise class tier. Those are that's heavy I/O when it comes to the endurance and the wear on the drive. Read, again, 2,000 years you can read to these drives, no big deal at all. You're perfectly fine. So we watch that data, and what we'll do is we'll actually, if we see heavy reads go into to a block, we actually promote that to the consumer-grade drives and get it out of the enterprise class tier, because the way we do it, enterprise class drives are more expensive. We have more consumer-grade drives, and one of the questions I'm surprised didn't come up, well, what about the performance difference between the two? There is a degradation, but we have double or in some cases triple the consumer-grade drives. it absolutely makes up for the half of the performance that they are. And then what happens if you write to that Z block, which is in the read tier? Well, we have an in-lift caching algorithm to say, okay, hey, whoa, that one would go to the read tier, negative, Ghost Rider. We're going to go to the write tier right there. You like that?
Oh, love it.
A little Top Gun. So anyways, we immediately put it in the write tier, so then you're rolling with endurance there. Then we'll watch it to see if it, again, is reads and that was just a simple update, or if it's now all of a sudden a hot write territory, and then we'll keep that in the write tier and basically promote it up. So with that being said, you know, drive replacements, all that stuff, we do have full support, 24/7 phone support, hardware-free replacements next business day standard. We do have Storage Plus where there's 4-hour on-site available. And then, of course, this is talking to personalized support in Atlanta, Georgia. This is where actually we're sitting right now. And this is actually where the QA team also is, the dev team for this product, all that stuff. And then the people you talk to are engineers. This includes a pod of people for virtualization, databases, VDI, and we kind of get those minds together. So depending on what the customer situations are, they can get a quick answer or just have that guy on the phone immediately. And then this basically eliminates the dumb questions. I mean, you know, do you have this thing plugged in? You know, what have you. And then, of course, email alert monitoring from our storage support team 24/7. And then this also includes things like proactive drive replacement. So you know, we have insight into these drives. We send out alerts once, say, the endurance gets low on the SSD or the medium error count gets high on the HDDs. And then what we'll do is send out a drive, hey, replace this in the evening or the next weekend or what have you. So, you know, you don't even have an abrupt failure in that regard. So kind of take care of all those things for you. And, of course, the hardware, it's all dual controller hardware like we talked about before. Power supplies, they're agnostic from the controllers, so you don't have to worry about that. And, of course, everything in the controllers, hard drive, everything's redundant in that regard. And you can also optionally, maybe, you know, the Storage Plus comes with the FRU kit, field replaceable unit kit. But you can also just buy that instead of, you know, doing the full Storage Plus. You're going to wait on the guy. He's going to come in. How many times do you could just replace the drive if you had the drive? Well, now you could have the drive. So all that stuff kind of available as options. And we have a lot of customers that do that. And then debug dumps, very simply just click of a button, create the dump. You can download it locally. Everybody gets their own FTP site from our support team. So. And then obviously the opposite for updates to where you can basically download the update or just go via patch and stuff like that. So now, how do we stack up against other vendors? Who the heck is AMI? I've never heard of StorTrends. These people are a joke. So we're not a good marketing company. This is our marketing. You're welcome for the pizza, by the way. But we've done what we can when it comes to getting our name out there with respect to other vendors and what, you know, kind of we find value in when it comes to spending our money for marketing, you know. So we did actually send the storage review. This is a completely agnostic test. They put us in the same exact environment as all these other vendors, and so then they say, okay, how do you score up against them? Now, SQL Server, transactions per second, we were top mark, and this is the latest chart. You can see the T-Gallons highlighted there, but we're the legacy incumbent there. And so we're still at the top of the mark there, and of course you can see even more importantly what I harp on is latency. 41 milliseconds at that 6200 load versus everybody else's over 100 milliseconds. There's so much technology in the way that we're maximizing the hardware. And then I don't do SQL. Okay, well if you do VMware or some sort of VM type situation, doesn't matter for us. We're just looking at blocks here. You can see basically who the blue ones and the green ones didn't make it up to 10. The blue ones didn't make it to 8, and you can kind of see who's correlating there. And then we're top of the mark when it comes to the 10 tiles, which each tile is basically 100 VMs, so it's kind of 1,000 VMs at 10 tiles, just hammering away different tasks and stuff like that. If you go outside of that, actually what just got released 9:30, so a day ago, 2 days ago, was the DCIG Buyer's Guide. And this is the all-flash array, basically just kind of where we're at there. So you can see that these other solutions above us, they might be recommended or best in class, but they're also 5 times more expensive than we are too. It's ridiculous. So that's fine. We'll stay at excellent and no big deal. so much more value that we're providing to everybody than anybody else. So feel free, go to storagereview.com, go to DCIG, go to, whatever. Look us up. No problem at all if you don't know who we are and stuff like that. And quite honestly, get a POC from us. No problem at all with us. We'll put it in your environment and prove what we're saying is true. A lot of installations, a lot of verticals. You can see kind of retail to, government, low-level government or high-level government, top secret stuff, to even, behavioral health kind of stuff, all kinds of different verticals that we're in. Radiology actually is a weird niche that we've had lately, and stuff like that. So universities and stuff like that, and doing a bunch of different types of workloads. So if you kind of dig into a few of these examples, 50 terabytes on the top left, he's doing electronic health records, bunch of SQL, VMs, databases, and all that stuff, replace the .hill SAN. Aquatech, they're out of Pittsburgh. They're a huge pipeline manufacturing company. Not a lot of capacity, not a lot of IOPS, but, centralized storage, and they're just trying to consolidate everything down and get their performance better. They want things faster and stuff like that, including TGI. They were actually a repeat customer. They bought our units 9 years ago, something like that. They're doing bidirectional replication between their two sites. And Site A and Site B, one has infrastructure, one has their warehousing information, and they replicate both ways and stuff like that. And then there's like UT Dallas who's doing brain research and stuff. So a bunch of different workloads and stuff like that, different capacities and all that. So that's kind of how all that works together.
Very good.
Do you have a specific question or anything like
Nothing
that?
yet. We thank everyone for their time. We're almost at the top of the hour here, and we will conclude at 2 p.m. Eastern Time promptly. Right now, James is just kind of going to go through a quick demonstration of the product, be fiddling with it, showing you things, how to create a volume, how to allocate space, different things there. If you have any further questions, feel free to shoot them on over. We may not be able to get to them within the top of the hour, but we'll be sure to shoot you an answer some way, shape, or form this afternoon with our appropriate response. But other than that, James, if you just kind of want to walk them through for the next 3 minutes or so on the demo, that'd be fantastic.
Yeah, absolutely. So here you can see the first report, basically showing overall storage statistics, just kind of giving an overview of performance. And then the second screen is kind of digging into each individual volume. And then here, one thing people like to see is it's an actual picture of the unit when it comes to hardware health. You can see the usable I/O by tier. So you can see the green tier, the consumer grade drive, yellow or the enterprise class drive. And basically, we're kind of watching that I/O load and doing what we need to in there. Here you can see I have a little red mark on the rear view. Basically, you can kind of see, okay, we have network interfaces unplugged. So you can kind of see the status of that. And I have multiple networks here, 1011, 5.5, 7.7, 10G, and another 7.7.2 is another 10G network. If you did have multiple enclosures, you just select that and then select down, basically kind of go from there. The other thing, event logging, that does come from both controllers. Here you can see dashboard. So we have SNMP network UPS capabilities as well as USB or serial, just depending on what you have in your environment. If you do want this plugged in, if it goes from AC power to battery power, we'll then go straight to write-through mode for all the caching and stuff like that. Once it comes back to AC mode, then we'll basically switch it back to write-back. So we do try to worry about those kind of things. A lot of people in that situation are using a generator. However, it is available. Updates, just simply either download it directly from the FTP or from a patch. Just hit choose file. And, of course, I have the patch on my network share right here. Hit open and then do an update. Obviously, I'm not going to do an update right now. Mine's up to date. Debug dumps, again, it's the opposite. You can kind of create it and then either download it locally and then upload it via FTP. And then one thing important is always email alerts and how that's kind of configured. You just simply select this, put in your email IP, and then you can see here StorTrends alerts at AMI.com. This is our support team. I would have this enabled if I were a customer. And then James D at AMI, if you want to yell at me or just make fun of me, whatever, email me up, no big deal. And here you can basically select what options you have there. And then if it comes down to each individual volume, we put this low volume here. I believe this has some okay, we promoted this up. So we started writing to it, but yesterday, basically, we had this all down here on the read-intensive drive because we were only reading to it. So you kind of see the usage space by tier and stuff like that. And then you can also see, if you want to see an overview of kind of how the access is working, you got it right here.
Very cool, very cool. We're at the top of the hour. Thanks so much, James, for that. If anybody else has any questions, we'll leave the presentation up here for a minute or so. If anybody wants to shoot over any last-minute questions that we'll get to. Like I said, if we weren't able to get to your question on air today, we'll reach out to you this afternoon, hopefully with the intentions of answering that question for you. Other than that, once you log off, you should be redirected to our website where you can kind of take a look and browse the things. If anything that you want more information on should be available there for you. Other than that, thanks everyone so much for your time this afternoon and for giving us your peace of mind. James, did you have anything else for the nice people before we let them go?
Nope. Thanks for listening to us, and yeah, hopefully we'll hear from you.
Yep. Thanks so much, everybody. Have a wonderful weekend. Please reach out to us with any questions or anything like that you need. Like I said, the demo will stay up on here for a few minutes if you want to watch as James kind of messes around with it, shows a few things. But other than that, thanks again, and we look forward to hopefully speaking with everyone soon. Bye-bye.